Hello everyone. In this webinar we're going to talk about transient capture tests and the usage of our RULA 17 data recorder. Also, before we start, let me show you our setups and explain some basics. I hope I'll make it interesting and worthwhile. So let's start. What is transient capture? Transient capture is a type of shock test used for recording and analyzing shock events. Also, transient capture is often required during shock testing, drop tests, and the shock machine's usage. You can use transient capture when you need to compare the shock with the required task. This procedure includes trigger, filter, and pulse parameters and subsequent analyzing or comparing with the ideal pulse. Also, this feature may be very useful for shaker manufacturers. So let's continue. There are different spheres where you can apply shock testing and transient capture. There are some main spheres like aerospace engineering, explosion monitoring, also transportation. You can also calibrate your accelerometers using transient capture and test amusement park equipment like roller coasters. And now let's talk about our first setup. Here we have one RLC21, which is connected with our head model, which has a 3-axis accelerometer, which is built in. And now I'll show you this setup. I think now you can see the video, and also here you have a picture. There is a head here, and it will be dropped on the playground surface. So now let's go to this probe cell. And here we need to create configuration for our first setup. Let's go to configuration tab and go to channels. Let's add a new configuration and call it webinar 1. Here you see that we have on the first channel we'll have an accelerometer which is 10 millivolts per G, and let's change its type to IP. The second one is also 10 millivolts per G and IP type, and the third channel will also have the same values. Let's apply the settings. And now let's create a test. Let's go to the main tab and open test settings window. As you see, this test settings window is a bit different from all other tests, but let's talk about each panel. The first one is pulse. If you need to compare your shock event with a required task, for example, with a half sine shock, you can enable this feature, and after the shock, you'll be able to compare the results. In this case, we won't use this feature. Also, let's go to SRS table. Here you can enter your SRS parameters, and in that case, you'll be able to draw an SRS task for this test, but we won't use it in this case also. And the main tab here is trigger and filtration tab. This tab is used to set triggering parameters of our shock, and after that we will set filtering parameters. So in this test we need to set the synchronization of this shock we're going to get. We'll set the positive front. Also, let's set our level to 2G, and then we need to set time before shock and after the shock. Let's use this feature, so we need to enter only one value, so it will be same. I mean that the time before shock and time after shock will be equal. Let's set it to 10 milliseconds. After that, we need to set our holding time. Let's set it to 2000 milliseconds. We don't need to set maximum analysis frequency because we're using auto sample rate feature. And let's enable trigger by absolute feature. In that case, we will analyze the absolute shock values. After that, we need to create a filter for our tests. We will use a low pass and a high pass filter. Let's set firstly a high pass. Let's set its frequency to 3 Hz, and let's leave high pass filter front as minus 120 decibels per octave. I think this value is good for this test. Also, we need to change our low pass filtering frequency and set it to 2000 Hz. And the low pass filter front will be the same. And now let's set shock frequency measuring period to 5 seconds. Now let's go to SRS parameters tab. And here we will use this tab. We will create an SRS graph in this test. And I think such kind of parameters are very useful for transient capture. And then our final step is to set our channels. Let's go to Channels tab and select Webinar 1 configuration. We will also turn on the third channel, and you see that the fourth one is disabled. As I mentioned earlier, we have a 3-axis accelerometer, but we need to capture the shock by only Z-axis. So we will use feature which is called block only, and our second and third channel are connected with X and Y axis of our accelerometer, so we will set block only feature. And in that case, we won't capture shocks by this axis, but we also will get only data. Let's apply our settings and press OK. Do we have any questions?
Yeah, as a matter of fact, there is some question about the structure itself. What is a head model?
This head is made for head injury criteria calculation. We have a special software, and this feature is used there and it's been developing now. And about this head model, it's a metal sphere with a built-in accelerometer, and I think its main usage, the use of this head will be important in playground certification. And we use this object in this setup because it's the most illustrative way to show the transient capture. And
yeah, so I just wanted to add that you will see the drop and the shock, and you will see the graph, and it will be just easy to compare. That's why we chose this particular setup.
So now let's start the test. And you see that now we need to wait some time because here you can see the phrase that transition is in progress. And let's wait some time. I think you can see the video well. Mm-hmm. If you have any questions or some video problems, please write a question. And now we are ready to drop the head. Here you see, let's create acceleration versus time graph. And now we will drop the head again. My colleague will connect it with the magnet right now. And here you see that we registered a shock. Its amplitude is rather high, and the head is dropped again, and you see the shock. Now, I'll show you one interesting feature in transient capture. You don't need to stop the test when you want to change the settings. So I'll show it right now. And to see the difference, I will copy the line of the first channel and change the settings. Here we will set our triggering level at 10G. Let's apply these settings. Also, we will change a filter a bit. Let's set low pass filter to 1000 Hertz. And also we will apply the settings. And now let's drop the head again. Here you see that graph has changed a bit, and now let's copy the line. Here you see that it changed, and now let's copy our new first channel line and change settings again. Let's set low pass filter frequency to 500 Hertz. Let's apply it, and let's create a new graph. The head is dropped again, and here you can see, I'll scale it. Here you can see that some waveforms were filtered. Do we have any questions?
Yes, a question. Can you measure velocity and displacement during transient capture?
Yes, let's create some velocity versus time graph. And also we can create displacement versus time. Let's close this, range graphs. And as we enabled SRS feature, you can create SRS versus frequency graph. It will be drawn after the next shock, and spectrum graph. Can we drop the head again? So I think now you can see these graphs, and it was a drop test. So now let's move on. Let's close the graphs and let's talk about the next thing. Let's stop the test. Now let's talk about our shock recorder RLR17. It has two different types of acceleration measuring. It can be working at plus minus 15 G and plus minus 190 G. Also, it has a frequency range, which is shown on the graph. Also, it can measure temperature. It has a wide range. And you can see that its battery life is rather high. Now let's talk about our setup. We have ROC21, which is connected with two sensors on the plate. And on the back of the plate, we have RLR17. And the hammer will create a shock pulse by this plate, and we will register these values. Here you can see the picture of our setup, and now I'll change my sensors on ROC21, and I will show you the image. This one is the left one. Let's turn on the camera. I think you can see it well. And now we need to go back to this probe cell And we need to turn on the RULA 17. Can you help me? Now let's create a new configuration for this test. Let's go to Configuration tab, go to Channels, and add a new configuration. Call it Webinar 2. Okay, we're using two sensors. The first one has a charge type, and its sensitivity is 1 picocoulomb per G. The second one is APE, and its sensitivity is 0.532 millivolts per G. We won't use the third and the fourth channel, so let's apply our settings. And now let's go back to the main tab and set our test settings. We won't use pulse tab and this rest table. Let's go straight forward to trigger and filtration tab. Here we need to set level equal to 20 G. Time before shock will be set to 100 milliseconds. Let's set times are equal. After that, the holding will be also 2000 milliseconds. Here we will use trigger by absolute, and then we will need to change our filtering parameters. High pass filter frequency will be set to 1 Hertz, and the low pass like this. So let's go to source parameters. We will use this feature, and let's go to channels. Here we select Webinar 2. Let's disable the third channel and disable log only. So let's apply. Okay. Now we need to start our transition progress. And is RULA measuring? Now I need to tell you some information about RULA 17. When you turn it into a measuring mode, you need to press and hold its button. In that case, its LED will blink red for some time. That means that this device is measuring the zero offset, and after that, when the LED stops blinking, you'll be able to create shocks. So our transition process is complete. So now let's create a shock. Now let's open some graphs. Let's make another shock, not so hard. Here you can see it. Let's make another one. And another one. Let's open some SRS graph. Let's make another shock. Here you can see it. And now let's stop the test and watch on our software for RULA 17. Let's connect it with the PC and turn on the camera. Do we have any questions?
Let me check. Can we export data from RULA 17?
Let's wait a bit. I'll show you this feature. Now I need to connect our RULA. Here you see a message which shows that our device is connected, and let's go to our special software which is called VShock. Here we can set our device parameters and download data from our device. Let me show you some settings, for example. Now we will show you our current configuration. Here you can see that you can change our measuring range, change sample rate, We have two modes, continuous recording and shock recording. Also, we can enable feature and our device will start recording automatically by time which is set. And here you can see, like in VisPro software, you can set our shock parameters like in Transient capture test. So now let's download data. Here you can see the recording. Yes, our data was successfully downloaded from our device. And here you see the graph about export. Here you can see our test, and here you can export the data. For example, you can export it in our format, which is called BioFix, and use it in VisProbe and VisAnalyzer if you need. Here you can see the graphs. And about accelerometer calibration, let's go back to VisProbe SL. If you have some kind of a shock machine and two accelerometers, you can place it on your shock machine and make some shocks. After that, you need to compare the graphs, and in that way, you will be able to calculate the FRF of your sensors and compare them and calibrate them after that. In that case, transient capture can be used for accelerometer calibration. Now let's see some values on the graphs. We have another type of cursors on the graph. You can set auto user maximum. Let's auto scale and set. Here you can see that our maximum shock value was about 200 G. And here we had another shock at 100 G or about so. Let's go to this shock. And here you see that the shock at 200 G was also recorded. So that's a good result. And you see that the data is really near at VisProbe and VisShock. So our shocks were registered rather at good precision. Also, here we can create a temperature from time graph. Our temperature in the room is about 19 degrees. So I need to say that when you start recording, our RLR is measuring acceleration and the temperature. And now we're developing a new version of RLR 17, which will be able to measure humidity. And in the nearest future, we'll create a new device which will have some different measuring sensors. For example, it will have a GPS tracking, it will have temperature sensor, a better acceleration sensors. And now I think we have some questions. Do we have some?
Yeah, I got lost a little bit. Can you capture the shocks on multiple channels at the same time?
Yes, as I mentioned earlier, in this setup, we're measuring our shock by two accelerometers, which are placed on our metal plate. And in the first setup, when we used a head, we have three sensors which are connected. Oh, sorry, we have one sensor, but it is 3-axis accelerometer, which is connected with three inputs of our RL C21. And we see that we have another question about shaker verification and its use. Transient capture is really important during shaker verification. For example, you know that you will make some different shocks with known amplitude, known task, and using transient capture you can go to test settings and use shock profile and create your task. After that, using your shaker and other controlling system, you can create the shocks, and using transient capture, you can compare the results and maybe some kind of correct them or check if your shaker is ready for the tests. In that case, I think transient capture is really useful for shaker manufacturers. Let's see if we have another question.
Yes. So guys, can we see SRS versus frequency graph in this shock, or we only see raw data?
Yes, there is SRS versus frequency graph in this shock, but in newer version, not in this one. There will be.
Which will be when?
This spring.
The spring. So this is the oncoming soon
Yep.
version. So basically, yeah, we can do that. All right, there is one more. How can I find the maximum amplitude value to be measured?
So let's go to this probe cell, and here so let me think a bit. I think you can find the maximum amplitude value by your sensor sensitivity. For example, our RL321 has the maximum values of 10 volts and 10,000 Coulomb on the channels. So you can calculate the maximum amplitude value by dividing this value of 10 volts or 10,000 picocoulomb by your sensor sensitivity, and in that case you'll get your maximum amplitude. So I think that's the answer.
So let us know if it answers your question. Thank you. Yeah, I don't think we have any more for now, but we have a little more time. So if you have questions left, please use this time to ask them. And meanwhile, we'll just show you a summary of what we wanted to tell you today. Yeah, so we wanted to show that the RULA software supports the functionality which allows you to work with shock and drop machines, and that is transient capture. Yeah, and it can be used for a variety of functions like shaker verification software. Please let us know in your feedback if you're interested. We can tell you more in our further webinars about this functionality. It can be especially interesting, I guess, for shaker manufacturers. Yeah, it may be used, the transient capture option, for comparing sensor FRF and sensor calibration. Yeah, and we wanted to introduce our basic RLR17 shock logger. It's quite efficient for transportation right now, has 30 days of continuous operation on low sample rate, and so very good battery life, wide frequency range. So if you are interested, please let us know. We'll be happy to give you more information about this device. Let me check if we have more questions. No, not for now. Then thank you, everyone. Thank you for your attention. We're going to give you a follow-up on this webinar with the webinar information, the recording if you need it, and we welcome your feedback. Please follow RULA social networks, our LinkedIn, the announcements on our website, and we will come back soon with more webinars. Thanks for your participation and your attention, and have a nice day. Bye-bye.